let me do the slideshow. Okay. Fourth without fourth.
For building scalable websites to run your online business. Tesla currently has some of the most efficient and performant electric vehicles on the road, especially given the price. The company has come a long way.
We've got some weird audio going on. Is that from you, Dr. Ting, or?
2000.
Yeah, I lost the computer. Okay, the summary.
Dr. Ting, your audio is really kind of odd. Is there anything you can do to adjust your microphone? It sounds very shaky.
Let me see. Am I online?
We can hear you, but it's very noisy. Are you using a wired microphone or something sounds very strange about your audio?
Yeah, it sounds very chopped up.
Okay. Let me just work along. So I talk about the fourth without fourth, but I would first mention what's fourth. Okay, I show a little bit of the simplified fourth GUI, and
yeah. Ting, there's a lot of distortion. Before you proceed, do you have another microphone, or is there some adjustment you carry?
You might try one of the different settings. If you click on the caret symbol next to the microphone and mute button, you seem to be getting some very big distortions.
Yeah, it's like packet drops.
Well, it sounds modulated.
Almost like a bad connection.
How about just the re-logging in?
I don't know how to do it. Okay.
Like single sideband.
What should I do? Let me just go through the slides, okay?
Dr. Ting, it might be worth trying to log in and out again. It seems like it's really hard to hear you.
Oh, okay, yeah. Oh, gee. Let me stop sharing. Okay.
While
Yeah,
Dr. Ting is doing that, I'd like to say to folks.
Okay, let me just leave.
Like to say to folks that we're still using Meetup and the payment is due. Also, we have expenses associated with the storage of the former Mountain View Press publications. So contact me, please, through Meetup or directly to forther@comcast.net. If you're willing to help us out with that. The rent is $150 a month for the storage.
Okay. Is it better?
Perfect now, Ting.
Okay, okay.
Much better.
Let me grab screen and start over. Oh, share sound. I think probably I missed that the share sound switch. Okay, let me start show. Is it okay?
Looks good.
Okay, good. All right. So in summary, I'll talk fourth in fourth, fourth without fourth, fourth GUI, fourth in JavaScript, fourth in Java, fourth in C++, fourth in Windows, and fourth for ESP32. Okay, first, fourth in fourth. Chuck Moore developed the first fourth systems. Then he compiled new fourth systems from existing fourth systems. And thus, he wrote fourth in fourth. When you give people the fourth in fourth, fourth becomes very mysterious. Fourth become fragmented because Chuck just wrote fourth in little bits, and he built up a big fourth system in small pieces, and the outer interpreter becomes mystery. Okay, there's lots of mysteries in fourth. When you boot up a fourth system, you go through the code, warm, abort, and quit. And after quit, you do the parse, you do the evaluation. And at the bottom of it, it's execute or compile. And then you have nest and nest. All these things are very difficult to understand. And so here, this year, I ventured out into the lands of Java, JavaScript, C++, and Windows. I tried to build object-oriented fourth. And I built several fourth virtual machines in other languages. And I found that better fourth could be built without fourth. And when I implement these new fourth virtual machines, all fourth primitive words, and there are many, and each of them has at least 100 of them. All these fourth primitives can be written in other languages. Outer interpreter and inner interpreter can be easily written and independent of the primitives. So I'm not using the primitives to build the outer and inner interpreters. And the fourth virtual machine can be greatly simplified. Okay, here is the GUI. In all these implementations, I basically wanted just an input box so you can type in words, and an output box which can show the result. So the fourth GUI can be extremely simple, and just to implement this GUI, it doesn't take much effort. So the fourth in JavaScript, that's the first one I tried, and it ended up as a JEForth 615. And it is in a simple HTML file, so you can load it on any browser. And we all need a fourth for modern browsers. And the dictionary and stacks are arrays in JavaScript. And JavaScript has floating point, and it also has all the transcendental functions. And you can build very significant browser applications based on this very simple fourth system in HTML. And then I tried it on Java. And Java, I really wanted to be object-oriented. And all fourth words are objects, all literals are objects, all control structures are objects, and you end up just with the object list, and you can just execute the object list very simply in the finite state machine. And so in here, Java has an AWT class, which allows me to put up two windows and do the input and output. And then I move to C++ with lots of help from Chu-Chien Lee, and we did the eForth 403. It was a C++ console application. And fourth word, of course, are objects, and dictionary and stacks are lists. And a fourth virtual machine executes bytecode. So we actually consolidated all the primitives into bytecode. And then C, once I have the C++ fourth, we just add the window interface to it, and it becomes the Win eForth 502. And a side comment is that Win32 is very complicated. But Windows might be complicated, but Forth should not. And so all we need from Windows are just an input box and an output box, and nothing else. And so Forth should not be complicated. And I think it is quite a usable Forth system with a minimum window interface. So it runs on Windows quite well. And of course, the goal of all this effort is to implement a good Forth system for ESP32. And it ended up with ESP32 Forth_85, which you can load down to the Arduino and get it running on the ESP32. ESP32 development kits, it is cheap and very powerful, and with Wi-Fi radio. So it is a very nice kit. And in this implementation, we move from objects back into a traditional dictionary, having the link field, name field, the code field, and parameter field. And of course, very interesting in the ESP32 is it has a SPIF flash memory. So we can actually store Forth programs or Forth applications in the flash memory, and thus you turn power on, the application in SPIF memory is compiled, and you get turnkey a turnkey system. So we intended to run a robot on the ESP32. And in conclusion, there are many benefits in the Forth without Forth system. So it is actually a new eForth model, and it's simpler and a much more efficient virtual Forth machine. And it is very easy to port. As I can show, we have already 5 different implementations on different languages and different operating systems. And we can take full advantage of the modern languages and operating systems, and make use of all their services. So I would like you to really look at this JE4 615. It is a simple, very short HTML file. And this is a link. I will put the link in the chat so you can download it. If you need any of the other Forth without Forth implementations, write to me. Chen, Hanson, Ting. Oh, sorry. This has to be SUN. Okay. I'll put that on the chat as well. So eForth still evolves. As you will recall, eForth, the version 1 was released 1990. And it has generated or caused the generation of 36 implementations for many different microcontrollers. And in the year 2000, I started to rework the eForth system into version 2. And basically all these implementations were optimized, the eForth system optimized by rewrite as many words into assembly as possible. So we have a number of implementation on that. And now we have eForth version 3. And currently we have it in JavaScript, in Java, in C++. And I hope many of you will take the model and move it onto other machines. Thank you very much. That's all.
That's fantastic. I can't wait for you to help us write the outer interpreter.
Oh, yeah, no problem.
Are there any questions? I would like to encourage speakers to send whatever links and other information that they want available in text to Dave Jaffe, who will put it up on the website. He has been doing meeting notes for every meeting since shortly after the Battle of Hastings in 1066 AD. And in general, I found that's the best way to publish links to new and exciting source code and things of that nature. It looks like Brad is ready to go. He's at the starting line. So if there are no other questions or comments for Ting, Brad, on with the show.
I do have a quick one for Dr. Ting. Which language was the easiest to write forth in of all the ones you used?
JavaScript, definitely. JavaScript is my preference because you run it on any browser, okay? And all other languages, you need the IDE to do the compilation and all the other good stuff, okay? But the JavaScript is very nice.